Hello everyone, I'm Guanhao Huang from UCLA. I'm going to introduce our work Generating Sports News from Live Commentary, a Chinese dataset for sports game summarization. This is a joint work with Chen Li from Tencent AI Lab and Kaiwei Zhang from UCLA. There are a lot of sports games playing every day, but manually writing sports news for every game is labor intensive. Therefore, some people start to study how to automatically generate sports news to summarize the sports games. In this work, we focus on generating sports summary from live commentary. The live commentary can be play-by-play records or the transcripts of the commentators. Here, we have two examples. We can see that the live commentary covers all the events in one sports game, but it's too detailed and not a summary. However, it's possible to generate sports news from the live commentary. To study how to generate sports news from live commentary, we construct a sports game summarization dataset called Sportssum. In Sportssum, we focus on soccer games and we crawl the data from Cigna Sports Live. After the data cleaning, we collect around 5,000 soccer games from 7 famous soccer leagues. For each game, we have a live commentary document and the corresponding sports news article. Sportssum is in Chinese, and we release our dataset in the following link. Let me introduce the data format for Sportssum. The live commentary consists of a list of tuples T, S, and C. T denotes the timeline information, S denotes the current scores, and C denotes the commentary sentence. The sports news consists of a list of news sentence R. In addition, we also include some metadata, such as rosters, starting lineups, or player positions. So now we can define the sports game summarization task. For the sports game summarization task, the input is a live commentary document C, and the output is a sports news article R tilde. We hope that R tilde is fluent and can cover most of important events in the sports game. And also, we hope that all the events described by R tilde is factually correct. We also propose a two-step summarization model for Sportssum. The proposed model consists of a selector and a rewriter. The goal of the selector is to select important events from the live commentary, and we treat this as a classification problem. We can see the figure in the right. Given a commentary document, the selector will make predictions on every commentary sentence to indicate the sentence is important or not. So we can get a set of important events, which are those sentences with positive labels. Then we can use the rewriter to convert the selected event to a news article. In this work, we focus on sentence label rewriter. That means we use a sequence-to-sequence model to convert each commentary sentence to a news article sentence. And our final news article is the list of generating news sentences. So how to train the selector and the rewriter? In Sportssum, we don't have the explicit label to indicate a commentary sentence is important or not. For the rewriter, we also do not have the ground truth to convert a commentary sentence to a news sentence. Therefore, we do sentence labeling and mapping. we label and map sentences by timeline information. As mentioned above, for each commentary sentence, we have the timeline information T. And we observe that for some new sentences, we also have the timeline information. So we can map a commentary sentence to a new sentence if they have the same timeline information. The detailed mapping process can be found in our paper. So if a commentary sentence CI and a new sentence RJ are mapped, then we can get a data point for selector to predict a CI as a positive label, and we can also get a data point for rewriter to convert the commentary sentence CI to the new sentence RJ. Therefore, we can use the collect data point to train the selector and the rewriter. However, we found a problem when training the rewriter. If we directly use a sequence-to-sequence model to train the rewriter, then we would have the name mismatch problem. That means the generated news contains a lot of high-frequency player names. Sometimes those high-frequency player names are even not in the commentaries document. To solve this problem, we train the rewriter in a template-to-template way. That means we modify the input sentences and the output sentences by replacing the player names with special tokens. By this way, the rewriter has to learn the relation between the spatial tokens and other soccer events instead of just generate high-frequency player names. So now we have a two-step summarization model, and we need to evaluate the model's performance. To evaluate the similarity between the ground truth news R and the generated news R tilde, we can use Rouge scores. However, we found that some news can have high Rouge scores but contains a lot of incorrect facts. Therefore, we propose two new scores for factual correctness. The first one is name matching score. This score is to evaluate the factual correctness of player names. Because we have some metadata, so we can identify all the player names in the ground truth news and in the generated news. And we calculate the intersection between the player names in the ground truth news R and the player names in the generated news R tilde. Similar to the name matching score, we define event matching score. This score is to evaluate factual correctness of events. We predefine some keywords to indicate some soccer event and calculate the intersection between the event in the ground truth news R and event in the generated news R tilde. So here are the experimental results. We can observe that our proposed two-step model performed very well on Rouge scores, name matching scores, and the event matching score. So let me conclude our work. In this work, we propose Sportssum, a Chinese sports game summarization dataset. We also propose a two-step summarization model consisting of a selector and a rewriter for Sportssum. In addition, we propose two scores, name matching score and event matching score, to evaluate the factual correctness. So that is our work. Thank you for your listening.